Okay, perpendicular lines. We're going to do this one kind of like we did parallel lines. I'm going to show you where the lines go, and then we'll talk about how the equations match. So first equation, A, the y-intercept is 2, and the slope is 2. So I think that's my blue line, and it's going to go through 2, and it's going up 2 over 1. So it's going up 2 over 1, up 2 over 1. So that's where that one is. My red line is going to go through 0, 0, and its slope is negative 1/2, which means it's going up 1 over to the left 2. If I can get it to go there's close enough. Okay. What do you notice about the lines? Maybe they're perpendicular. Okay, let's do the next one. Now these you of course have to solve, and we'll solve in a minute. But if you look at A, maybe you can go ahead and solve it while you're watching me do this. My x is going to go over to the other side and be negative, but my y is negative, so it changes to positive, and then I divide by 4, so my slope for A is going to be 1/4, and because I'm dividing by 4, it's going to go through 2, so it's going to look like this, and it's going up 1 over 4, close enough, close, never close enough. Oh, I'm going to be sorry I started this. Okay. B, when I move my x over to the right, it's a -4 for the slope. Since y doesn't have a coefficient, it's going to stay -4 for my slope, and my intercept is 3. So it's going to go through 3, and it's going to go, the slope is 4. So it's going to go up 4 over 1. So we're going to go down 1, 2, 3, 4, and over 1. It's close, but not perfect. Okay. Hey, these lines look like they might be perpendicular also. So let's go back up to the top and look at number 1. And let me get out my ink pen. I'm in the mood for green. Okay. So first of all, let's look at the equations. The slope is 2, and the y-intercept is 2. So that's my blue line. For the red line, the slope is -1/2, and there's no intercept, so it goes through the origin. So what do you notice about the lines? There's a positive slope and a negative slope. They're really close to perpendicular, if they're not. What else? I guess it's probably a right angle where they cross. Okay, when you look at the equations, you should notice that the slopes are opposite signs. And they're the reciprocal of each other. Now, for them to be reciprocal, you have to remember that if a slope is 2, that's the same as 2 over 1. So the reciprocal of that would be 1 over 2. So the slopes are the reciprocal, they're flipped over, and they have the opposite sign of the other one. Okay, that's all I wrote down. Let me know if you think of something else. Okay. For the second one, we have to do some solving, which is what I was talking about, which hopefully you were working on already. Okay, I'm going to do b first. Okay, so when I say solve for y, do I have to? No. After all that whining I did for y'all about leaving it in standard form, I can leave it in standard form too. All right, so I could solve for y, or I could just say, hey, what's the slope? The slope is negative a over b. So there's the slope. And the intercept is if x equals 0, y equals 3. So there's my point, and there's my slope, and there's my red line. Okay. For a, I can do the same thing. The slope is 1 over 4, negative 1 over negative 4. So that's 1/4. And if x equals 0, y negative 4y equals negative 8. So y equals 2. So there's my slope, and there's my point. And I've done those two lines, and I don't have to change them. The problem with not changing them is you have to find the slope, which is totally fine. So what do you notice about the lines? Hopefully you notice they're perpendicular again. We have a positive slope and a negative slope. You might have noticed, and it's going to be one of those things, in standard form, A and B is switched. A and B are switched. So one of them has the 4 by the x, and one of them has the 4 by the y. What else? Oh, one of them is negative. Let's see. A and B are one's negative and one's okay. So in A, B is negative in equation A, and equation B, they're both positive. So the signs are different, I guess we could say. And when we actually worked out the slopes, we saw that they were reciprocal and that the slopes had the opposite sign. So what can we conclude about the slopes of perpendicular lines? The slopes are opposite signs and reciprocals, which means you flip over the slope. So there you go. When they're parallel lines, the slopes are equal. When they're perpendicular lines, the slopes are the opposite and are flipped over. And if it's not the same or a reciprocal with an opposite sign, then they're not either one. They cross, but they don't cross at a right angle. Okay, so now let's do some practice. It should look familiar. It should, I think, look like what you did for parallel lines. Okay, so let's take let's take these 2 points this time. Okay, so it's going up by 4, and it's going up by 8. So my slope is going to be 8 over 4, which is 2. So if I have a perpendicular line, the slope is going to be negative, and I'm going to flip it over and make 1/2. Okay, easy. So for number 4, I have x1, y1, x2, y2. For my slope, I'm going to have 1/2 minus 2 over 2 minus 4. 1/2 minus 2 is negative 1.5, and 2 minus 4 is negative 2. So my negatives cancel out. I'm going to multiply everything times 2, and I'm going to get 3/4 is my slope. So the slope of the perpendicular line is going to be negative 4/3. Flip it over, change the sign. Okay, the slope for this line over here, I see perfect points at here and here. So the slope is, actually it's up 1/1, right? Up 2/2, so it's negative 2/2, which is -1. And if I have a perpendicular line, it's going to be a positive. 1 is 1/1, so it's going to be 1/1. So if you have a -1 slope, +1 slope, perpendicular. So let's find the equation of the line. So I have my slope is +1, and my point is right there. And so I have y minus 6 equals 1 times x minus 1. So that's an equation, but let's go ahead and simplify. Y minus 6 equals x minus 1. Add 6 to both sides. Y equals x plus 5. So here's my equation for that one. Okay. Here's an equation, x equals 8. Hey, Hoivax. So it's a vertical line with an undefined slope. If I have a vertical line, you should know that the perpendicular line is going to be horizontal. So if you have Vux, perpendicular line is hoi. So it's horizontal, 0 slope, and y equals, nope, x equals, oh, wait a minute. They changed it. Look at that, they changed that. Okay, so we're doing a line perpendicular to y equals 8. So that's my horizontal line. So if I want a vertical line, it's going to be x equals 2, because I'm just going to use that 2. And I can always do my equation, but it's not really going to work. So let's just do that. Okay, so number 7. So I'm doing slope-intercept. My slope is -3. So my new slope is going to be positive 1/3. So I have that slope, and I have x1, y1. So I'm going to have y plus 2 equals 1/3 times x minus 6. Y plus 2 equals 1/3 x minus 2, because 6 divided by 3 is 2. I subtract 2 from both sides. Y equals 1/3 x minus 4. Slope-intercept. Gee, I hope the next one has to be for standard. Oh, nope, it didn't. Not there yet. Okay, so again, slope-intercept. We want a perpendicular line, so I need the slope for this one. Remember, the slope is negative a over b, so that's going to be negative 2/3. So my new slope is going to be positive 3/2. So I have x1, y1, y minus 5 equals 3/2 times x minus 4. Y minus 5 equals 3/2 x minus 4 times 3 is 12, divided by 2 is 6. Add 5 to both sides. And I end up with y equals 3/2 x minus 1. Oh, good, standard form. Okay, standard form. But what kind of line is that? Oi, it's a horizontal line with a 0 slope. So if this slope is 0, my new slope is going to be undefined, which means it's a vex line, which means it's vertical. X equals, my x value is 1. X equals 1 is the perpendicular line to y equals -5 going through point 13. That was so easy. So easy. Thought this was a short video. All right. Perpendicular lines, important takeaway. If they're parallel lines, slope is equal. If they're perpendicular lines, slope is opposite sine and reciprocal. There's your takeaway for the day, and the practice should be so easy.